All right, everybody. It's a great pleasure to moderate the following session here entitled Microelectronics Security, a Growing National Imperative. And our guest speaker, I'm honored to announce Dr. Dev Shenoy, Principal Director for Microelectronics at the United States Department of Defense. To give a little bit of background, I mean, in my previous job, I was working in the software world, so at Federated and some of the other companies, and we were always quoting software, as eating the world. Mark Andreessen, you probably all remember, right? And software was just so big, and what everybody really forgot is that software runs on hardware, right? As at the end of the day, there's really hardware that's enabling our electronic infrastructure. And I'm very, very pleased, and many of you observed that over the last couple of years, the renaissance of semiconductor hardware, in terms of emphasis, emphasis on investments, in terms of emphasis on, how do you, build people and hire people, but also in terms of emphasis on the Department of Defense when it comes to, semiconductor as a strategic and national security imperative. So the honor I really have here, I have Dev Shenoy sharing a bit with us what the DoD is doing in helping investments, in helping initiatives to foster semiconductor, and particularly semiconductor security, right? That is really the issue. Dev and I, we talked a little bit earlier, and we spoke about how can we enable really the broader ecosystem, the broader community to get engaged here. And I think I'm very, very happy that Dr. Shenoy will share some of these thoughts on this. Just a little bit of background. Dr. Shenoy has a PhD in physics. And I'm always saying, physics is the queen of sciences, right? My PhD is in just electrical engineering, right? And you're a physicist, you know everything. You know the foundation of everything works, and that's very apparent in Dr. Shenoy's history. So he's currently responsible for all, the research and the engineering in microelectronics in the Department of Defense. Before, he had multiple leading positions at the University of Southern California, at the Department of Energy, and then also in various other positions. So Dr. Shenoy has seen a lot, right? And I'm very happy to have you on the stage.
Thank you for that kind introduction. As you exactly said it, I'll share a little bit of DoD's microelectronics. That is accurate, because I can't obviously share everything that we do. So once again, I'm Dev Shenoy. I'm the Principal Director for Microelectronics at the Office of the Undersecretary of Defense Research and Engineering. I'm also the Director for the Defense Microelectronics Cross-Functional Team, and in that role, we bring together all of the DoD components to inform our planning and programming and microelectronics, among other things. So, what I plan to do is provide you with a 30,000-foot view of microelectronics as it pertains to the DoD's needs and requirements, and be happy to answer any questions that follow after my presentation. So let me start with this slide here that talks about how microelectronics is a must-win technology for the DoD. And I quote this from President Biden's Executive Order 14017, that's a supply chain security related executive order, as you probably know. And it talks about how semiconductors are essential to national security, and they're fundamental to the operation of virtually every military system, including communications, navigation systems, and complex weapon systems, such as those found in the F-35 Joint Strike Fighter. And there's another excerpt there that's from the National Defense Science and Technology Strategy that's put out this year, 2023. And it talks about how the DoD will accelerate the process of turning ideas into capabilities, because that acceleration of turning ideas into capabilities is critical for us to stay at the leading edge, for us to have those asymmetric capabilities for DoD's weapon systems and platforms. And then that last excerpt there is one that was put out recently. It talks about the Chips and Science Act investment as it relates to the Department of Commerce's NSTC. That's the National Semiconductor Technology Center. And that technology center is really going to revive a lot of the microelectronics in the US here, and in close collaboration with the Commons. The Commons refers to the Microelectronics Commons that the DoD is supporting starting this year. And so the close collaboration between the DoD's Commons and the Department of Commerce's NSTC will help revive and reinvigorate the microelectronics ecosystem in the US, not just for commercial applications, commercial purposes, but for DoD's national security needs. So, we have our vision, mission, goals, and objectives in microelectronics. And so these are some of the objectives that are shown here. DoD's vision is to guarantee long-term access to the secure microelectronics. What that does is to enable the overmatched performance, because microelectronics underpins every system and platform that you can think about. And so it's clearly going to provide the overmatched performance and increase military operational availability as well as warfighter combat readiness. And in support of this broad vision, we've laid out a number of objectives. Timely access to that secure electronics is very critical, but it's also got to be affordable. Motivating the programs and the primes to modernize. We've got systems that have been around for literally decades, and so we've got to figure out ways to modernize our systems with the leading edge microelectronics that's available commercially. And so that integration, that insertion of the microelectronics into DoD systems and platforms is something that we're laser focused on. And as we do that, we have to leverage these tools, these policies that are critical to eliminate those costly sustainment issues in legacy platforms. For decades, DoD has supported microelectronics. Ever since the industry started microelectronics, DoD has been there as a customer. And so we've supported the discovery and the innovation, and we continue to support the discovery and innovation across, for example, through DARPA, through in other places. That's something that we are very focused on. The innovation is critical to think about those leap ahead capabilities and technologies that we are supporting. And then finally, we want to influence the interagency and national efforts, and this refers to the fact that we have, through the Chips and Science Act funding, $52.7 billion over the next 5+ years. And then so that investment of $52+ billion is to support not just DoD's national security needs, but also to ensure that we have a robust and resilient supply chain here in the US, as well as a very well-connected supply chain that spans across our allies and partners as well as the globe. So that's the vision for microelectronics. Now, when you think about DoD's challenges as it relates to microelectronics, this clearly shows what our challenge is, and it has to do with the fact that DoD over the years and over the decades, initially DoD was a major customer in the early decades, but over the years, that contribution has diminished to less than 1%. And so that's what is shown here. We have a very high mix, but that is meant digital, analog, mixed signal, FPGAs, ASICs, and so on and so forth. A very high mix, low volume requirement for the DoD. And then that's been a continuing challenge that we are trying to address. And if you look at the various sectors that the semiconductor industry supports, the DoD's, that sliver that is shown there is a very small fraction of the DoD, of the overall industry revenue. And it's obviously across all those components that are shown here. The additional challenge that the DoD has is, over the last couple of decades, the number of sources that the DoD has access to do the manufacturing has dwindled to just a couple of foundries at the leading edge. And then although there is a need to access microelectronics not just at the leading edge, but as well as state of practice and legacy technologies, across the board, our sources of access for leading edge microelectronics are essentially just Intel, Samsung, and TSMC. And if you look at what's available onshore, it is just one foundry, Intel Foundry Services today. And then so we want to grow the manufacturing base in the US. We want to sustain a supply chain that the DoD can have access to for all of the needs and requirements that I just talked about. So what's one solution or one approach to solving this high mix, low volume DoD's needs? And that is what is shown here. So what we can think about is aggregating demand across some of these various critical sectors. And some of the critical sectors are shown here, whether it's Department of Energy, it's the Department of Homeland Security, the transportation sector, the cybersecurity sector, as well as the industrial sectors, such as the banking sector, the medical sector, the financial sector. They have obviously needs for very secure microelectronics. And then so we want to leverage those needs that the industry has. We want to aggregate the demand that informs us of what those needs are. And that's got to be done in a very thoughtful process, because it's not just about access to a foundry, it's also about access to the design capability. It's also about access to advanced packaging capability. And then so we've got to have access across the ecosystem of design, manufacturing, assembly, packaging, and testing. And then so that's what we are hoping to accomplish through this new approach that we have shown here, which is the aggregation of demand. So we will have domestic capabilities to do the design, the manufacturing, advanced packaging, and so on for secure and safe microelectronics. And we want to show that there is a whole-of-nation approach to access the secure microelectronics technologies, because microelectronics, as has been abundantly clear from the presentations you've heard, is extremely complex, going to get more complex going forward because of 3D heterogeneous integration of analog, mixed signal, digital, and so on and so forth. It's going to get extremely more complicated, and therefore we have to have a whole-of-nation approach to assure the microelectronics that's going to be in our systems and platforms. So what this shows is how we leverage the industry roadmaps when it comes to microelectronics. Up until recently, as you all know, there was the ITRS. There was a roadmap for, transistor technology that we could look at and say, okay, here's where we're going to be in, say, 5 years or 10 years. But now we've got a number of roadmaps that we want to have to leverage. And so what DoD will plan to do is leverage the commercial microelectronics roadmaps to then build roadmaps. I'm going to show you a couple of roadmaps that we have for microelectronics for the DoD. And then through those roadmaps, we achieve our objectives that then lead to DoD's programs that sustain a lot of the platforms across the Navy, the Air Force, and so on. So that's the approach here that is shown. I want to show this in the context of some of our ongoing projects and programs. So what's shown on the left there, under S&T, the science and technology, are a number of projects that we will plan to support through what's known as the Microelectronics Commons. This is the $2 billion of funding that the DoD has through the CHIPS and Science Act, which will support a lot of technologies that I'll talk about briefly. The technology demonstration projects, such as RAMP, which stands for Rapid Assured Microelectronics Prototypes, RAMP. And then there's RAMP-C, which stands for commercial capabilities for those kinds of prototypes. And then there is the TNAM program. The TNAM program is the Trusted and Assured Microelectronics Program. And so this broad TNAM program is critical for the success of DoD's microelectronics, because the security is absolutely essential for us to support. And in the application platform that are shown there, whether it's the ships, the submarines, the aircrafts, and so on, they're all going to do a lot better with the capabilities that we develop in microelectronics. And so we want to bridge that lab to fab gap that's existed for many years, and I'll talk more about it shortly. But what this shows is how we support microelectronics across that early stage R&D, through the lab-to-fab prototyping, and then the maturation of those technology through the TNAM program, that's the Trusted and Assured Microelectronics program, and then eventually those transition into the platforms that are shown there. So let me say a little bit more about these two broad initiatives. One is the Trusted and Assured Microelectronics program, TNAM program, and then there's the Microelectronics Commons. So the Microelectronics Commons is really to ensure that a lot of the research that's being done at the universities, at the startups, at the small companies, eventually make it into products. Because there is this valley of death that's very well known, where the research is done, supported by places like the National Science Foundation, maybe DOE Office of Science, maybe even DARPA, but those technologies don't make it into prototyping capabilities within a foundry or a manufacturing facility, because the cost of that kind of endeavor is a lot higher. And so there is not the investment that's needed to do the prototyping. That's where the Microelectronics Commons is going to come in and support those kinds of initiatives across a number of technical areas that are shown here, such as AI hardware at the edge, secure computing, quantum technologies, 5G technologies, commercial leap-ahead technologies, and so on. So it's a pretty broad set of technologies we're trying to support with the lab-to-fab prototyping. And lab-to-fab prototyping is not just about some research that's done in the university or startup that's going to be manufactured in a foundry. It could be a design capability as well. And so we have to ensure that as we support these prototyping capability, we open up the aperture, we have a broad view of all the opportunities that exist that are funded by the National Science Foundation, by the DOE Office of Science, and other places. The TNM program, we are currently supporting a secure design cloud capability. And so the secure design cloud capability is to ensure that the industrial base has access to the PDKs, to the IP, the third-party IP, and all of the foundational IP, and everything that's needed to design at the leading edge. So the secure design cloud capability is very important for our defense industrial base, as well as the commercial industries that work with our defense industrial base partners. So that's the RAMP program that I talked about. SHIP is about advanced packaging and prototyping. It stands for state-of-the-art heterogeneous integrated packaging or prototyping. And so SHIP is supporting onshore access to leading-edge capabilities in advanced packaging, which is critical because, as I said, it's not just about design and manufacturing, it's also about assembly, packaging, and testing as well onshore. So through these two efforts, as well as RAMP-C, which is getting access to leading edge, and by that I mean a really leading edge, 18A technology. It's beyond the 3-nanometer technology that's currently in production at TSMC. So the 18A capability is going to ensure that DoD will stay at the leading edge. And the JFAC, that's a Joint Federated Assurance Center, it's a consortium of 4 DoD labs, which ensures that we have very good understanding of what the security challenges are for the DoD, as well as measures, countermeasures that are needed, solutions that are needed to address those security challenges. So let me show you a couple of examples of the roadmaps. This roadmap is for access to state-of-the-art microelectronics. The first one, that's the foundry access. What that ensures is that organizations have access to leading-edge foundry services in the US. So those kinds of accesses allow not just the universities, but also the defense industrial base companies and commercial companies as well in the future to have access to capabilities that will support the DoD's needs and requirements. RAMP is a program that I mentioned. RAMP is critical for us because it's focused on security approaches to support DoD's needs in microelectronics. When you think about security, and many of you are experts in security of microelectronics, what I have to emphasize is it's not just the security during the design process. What are some of the vulnerabilities? Maybe there could be an insider threat during the design process. Maybe the design tools are not trusted. When you think about manufacturing, how trusted is the foundry? When you think about assembly, packaging, and testing, there are several points of vulnerabilities, as it were, across that cycle that we need to address, that we need to develop countermeasures for. So any techniques, methodologies that we introduce have to take into account a large number of such challenges that we need to address. And then some of this is available in the open literature, whether it's side channel attacks, whether it's reverse engineering, whether it's insertion of Trojans. There's a number of security challenges that we need to address in a holistic sense, in a holistic manner, because if you just address one risk, that's potentially going to still open up other security vulnerabilities. And it's got to be done in the context of our mission scenarios. If it's on a satellite versus in the hands of a warfighter, different kinds of security needs and requirements. So those are the mission-specific scenarios that we need to look at as well. And then there is emulation and EDA tools that we support, which is critical for the DoD's design capabilities. And in the future, we certainly want to do more of those kinds of projects. I mentioned the JFAC, the Joint Federated Assurance Center. So the JFAC is this consortium of DoD labs that evaluates the assurance needs for microelectronics. And it's across all of those different kinds of components like FPGAs and ASICs and commercial off-the-shelf. Commercial off-the-shelf components are obviously extremely challenging because when you think about COTS or commercial off-the-shelf, they are sourced from suppliers that are global. And that global supply chain, there's only so much visibility into that supply chain, particularly at the lower tiers of the supply chain. And so you probably don't know who designed the chip. You probably don't know where it was manufactured. And even if you knew where it was manufactured, you probably don't have enough access and understanding of what was done in the foundry during, for example, mass fabrication. And so there's a number of things that we need to worry about when it comes to commercial off-the-shelf. And those are all challenges that we are addressing through the JFAC. So we have developed what are called levels of assurance that are shown there, depending obviously on mission needs and so on and so forth. And supply chain awareness, we have tools that we have developed to address this supply chain awareness challenge. And AMARO, which stands for Automated Microelectronics Analysis and Reporting Optimization Tool, that tool is to inform us of that supply chain and how robust and resilient the supply chain is from an economic standpoint, but also from a national security standpoint, being able to say that this particular component that was sourced from a particular source has the following vulnerabilities. So those are the kinds of insights that we need to be able to support insertion of those components into our systems and platforms. And so there's also software assurance. There are other tools such as the ACMA, that's the Attack Countermeasure Analysis tool that we support. And so those are all the efforts through the JFAC. Now let me pivot to some of the discussion on the CHIPS and Science Act funding. As I mentioned earlier, the CHIPS and Science Act funding is $52.7 billion over the 5 years. DoD has $2 billion of that for the Microelectronics Commons, and that $2 billion is over 5 years, starting in this fiscal year. So when I say this fiscal year, FY23 ends on the end of September. September 30th is the end of fiscal year. So by the end of this fiscal year, we would have implemented $400 million of effort, Microelectronics Commons efforts, in the first year. And in the next 4 years, we'll have another $400 million on an annual basis to support those projects in the Microelectronics Commons. And they are very synergistic with what's being planned through Department of Commerce's NSTC, the National Semiconductor Technology Center. And what is shown here is how at that early stage of research and development, there is support from a number of sources because the scale of investment is obviously a lot smaller when you think about research and development. You could probably do it for $500,000 or $1 million, but when you think about prototyping, you are really talking about millions of dollars. So that's been the challenge. And so we are hoping to address that through the Commons and the NSTC, and further maturation of those technologies will require private capital investment. And so we certainly want to ensure that as we mature those technologies, that there are those private sources of capital to partner with us. I'll give you a quick example. When I was a DARPA program manager, I had a program called STT-RAM, Spin Talk Transfer Random Access Memory. It was a non-volatile memory technology. In the third year of the program, there were a number of venture capitalists who stepped up and helped scale the technology. It was a small company. It was called Grandis, Milpitas, California. They got bought up by Samsung, and the technology is commercialized. So those are the kinds of successes we want to see with the technologies we support through the Microelectronics Commons. And again, sort of to set the context for the Microelectronics Commons, the goals of the Microelectronics Commons is to ensure that there is domestic access to the capabilities that are needed for our universities and startups and small companies to be able to be a lot more successful than they've been in the past. And because, when it comes to large companies, they can obviously get their access to foundries and EDA tools and so on and so forth. But it's the small companies, the startups that struggle to have their access to foundries, access to EDA tools, access to the licenses that are critical to be able to design and manufacture the leading edge. So those accesses are going to be provided through the Microelectronics Commons. So the goal is to democratize access to microelectronics capabilities, and that's what the Commons is all about. The core facilities and the foundries, again, we will provide access to those fabs for the prototyping that's critical for the success of microelectronics. And it will help address some of these impediments, such as the tools that are needed, the foundry access that's needed, and so on and so forth. And this slide here shows in some more detail exactly how this is envisioned. So there is the research that's done at the early stage, and there is the value of debt that we are trying to address across those various technical areas: electronic warfare, secure edge computing, AI hardware at the edge, which is timely given the tremendous interest and excitement about AI. So we have to have AI hardware to actually support a lot of the AI-related investments that are going on. Quantum technologies, 5G, 6G technologies, and commercial leap-ahead technologies. So commercial leap-ahead technologies are those technologies, it's a broad category that the commercial industry has not yet identified as commercial opportunities. And a good example of that is gallium arsenide technology about 15 years back. Commercial industry did not recognize gallium arsenide had the kinds of potential that it has today. And so that's an example of a leap-ahead technology that we want to support through that commercial leap-ahead category. And it could be pretty much any technology that we are interested in wanting support for. And so I would encourage anyone that's wanting to be part of the Microelectronics Commons to look into what the Commons is trying to do to be part of the Microelectronics Commons. Now, the core facilities, those are the foundries. Those foundries could be digital foundries. They could be, foundries that provide access to analog mixed signal capabilities, because when things like electronic warfare, 5G, 6G technology, and so on, it's not just about digital technologies. It's also about, compound semiconductors like gallium nitride and gallium arsenide and so on and so forth. So we want to support a broad range of technologies to enable the DoD to have access to all of the capabilities that are critical for those asymmetric capabilities. And what's shown on the right of the graphic here is, the commercial industry, the defense industrial base, the defense programs, they are critical for the success of the technologies that are being advanced through the Microelectronics Commons. Because as you mature those technologies, for example, through the NSTC that the Commerce Department is going to support, we want to ensure that there is efficient handoff to the private sector. It could be the defense industrial base as well. The defense companies will need to step up once they realize that those technologies are mature enough for them to then support it going forward. So those are the kinds of opportunities that we want to enable through the program that we have just recently started. Again, this program is in source selection, which means that we've received the proposals, we are evaluating the proposals, and we will announce who the winners are, in a timely manner. Because, as I said, there is the $400 million per year on an annual basis that we need to obligate and execute. So with that, I'd just like to summarize some of the key points that I touched upon. DoD faces many challenges because when it comes to microelectronics, across all of those platforms, Navy platforms, the fighter jets and the Army platforms and so on and so forth, they obviously span a broad range, a broad spectrum of capabilities. Microelectronics that was developed probably in the 60s and 70s is still being used today in our systems and platforms. So we have to be able to support an ecosystem that provides access to those critical capabilities, for those bespoke needs, state of practice as well as leading edge as well. I briefly alluded to how aggregating demand across those critical sectors might be an opportunity for us to do a lot better for the DoD, because the DoD obviously its needs are 1% of the overall industry's revenue. But if we think about partnering with our critical sectors, maybe we can do a lot better. And so that's an opportunity we want to explore a lot further. Obviously, there are a number of challenges that I alluded to. It's not just about manufacturing, it's not just about design, it's also about assembly, packaging, and testing. And it's also about a business proposition that makes sense. And so we have to have that access based on the business proposition as well. And I talked about the roadmaps that we developed. We certainly are going to ensure that DoD will have access to leading edge capabilities for advanced packaging, testing, and I talked about the JFAC, the access to the capabilities that are critical for DoD to have assured microelectronics, the secure microelectronics. And I finally talked about how the DoD and the interagency are planning the CHIPS funding related investment. And it's a true interagency effort. But that I mean, it's not just the Department of Commerce and it's not just the Department of Defense. It's across all of the departments, the Department of Energy, the National Science Foundation, the State Department, all of those are involved in planning for the CHIPS and Science Act funding to ensure that we have a robust and resilient supply chain. And so in closing, I want to say that what we are really focused on here is democratizing access to microelectronics capabilities for our startups, for our small companies, for our universities, for our large companies, commercial companies, defense industrial-based companies, the FFRDCs, those are the federally funded research and development centers, as well as the UARCs. So every category of stakeholders, if you will have access to those microelectronics that we are planning to support. And with that, I'll close and be happy to answer any questions.
I want to start off with one question, and that is, you mentioned at the end, startups and small companies, and the audience here, the participants at Design Automation Conference, a lot of participants are either from academia, from smaller companies, on the innovative front, but really mostly engaged on the commercial side. I think one of the questions I have is, for smaller company or startup, sustainable funding is a key effort.
Yes.
And I think many of us know the government, can be slow, it can be unpredictable, and that is for a lot of people, I think, really kind of a big question mark. Should I get engaged, right? Should I get engaged in a way, that we can participate in the exciting, topics that you mentioned? So maybe you can comment a little bit on that.
Yeah, happy to talk about that, because I certainly think that we should not only encourage and incentivize the startups and small companies to participate, we need them, because when you talk about innovation for microelectronics, it's the startups, the small companies, and obviously other universities and places are important as well, but very important that our startups and small companies participate in our efforts. So let me start with that. Because the innovation comes from the startups and the small companies, and if you look at the history of successes in the companies in the US, the technology companies in the US, they were all small companies and startups, that obviously have grown into multi-trillion in companies in some cases. And so without a doubt, we want to support the startups and small companies. Now, how do the startups and small companies get access to what I talked about. So let's say the funding or an opportunity to partner with us on these programs. It's really a very simple thing to do, which is we have a non-profit consortium in place. It's called NSTXL, which stands for National Security Technology Accelerator. And that NSTXL nonprofit consortium is our intermediary, if you will, with the government or with the DoD. In this case, it's Navy Crane. So what we do, when I say we, within the Office of the Secretary of Defense, we have Navy Crane manage our programs in microelectronics. And so Navy Crane has NSTXL, and so it's really a simple matter of the startup or the small company reaching out to NSTXL. Now, let me just emphasize that if you go to the private sector, whether it's the venture capitalists or whether it's maybe a bank in the Silicon Valley, there are processes and diligence that have to be done. And so when you think about what startups and small companies go through for the private sector funding, it's not too different. They've got to figure out how to get access to the funding and what are some of the sort of the criteria, as it were, whether it's a slide deck or whether it's those early conversations that lead to that eventual funding. There are processes in place that you have to think about. And I would encourage those startups and small companies that have not worked with the department, with the government, to partner with one of the hubs that we will select. The hubs are a collection of organizations, in a region, or it could be across the country. So these hubs are going to be selected in the Microelectronics Commons. One way the startup and small company can partner is with one of the hubs that are forming. So let's say there is a hub in the area that is being selected. This startup or small company could reach out to the hub and say, we want to be part of the Microelectronics Commons. And that hub lead will ensure that the ideas that the startup and small company have are shared with the DoD. And so that's that process that I would encourage that you look into. And it's really a simple matter of looking at the NSTXL website. There's tons of information on the website. There's Q&A. Before we put out a call for proposals, the RFS as it is called, Request for Solutions, there were a number of questions that came in, and we answered all of those questions, including from startups and small companies. And so, there's a ton of information on those links that are provided by NSTXL that I would encourage you to take a look at to be able to partner with us.
Thank you, Dr. Shenoy. I think when you mentioned banks in Silicon Valley, some of us have some traumatic memory.
And that was the intent. And that was exactly the intent, that you understand that, there is always the risk that you have to keep in mind. So whether you go to a bank in Silicon Valley or whether you go to a DoD sponsor, you always have to think about the risk profile, right? I mean, how are we mitigating the risk? How are we addressing the risks? So, when we look at proposals, we evaluate them based on a number of criteria. What's the impact for the DoD? What's the economic impact that this microelectronics capability is going to have? What is the risk profile like? And in fact, those of you who have worked with DARPA are probably aware of the DARPA Heilmeier criteria. That's something that I've used for many years because I had my programs at DARPA obviously based on the Heilmeier criteria. Really good set of criteria to look at. What problem are you trying to solve? How is it done today? What are the successes that you can envision with that new technology that you're trying to develop? So I would encourage those who are planning to work with us to start looking at those kinds of criteria and prepare a slide deck that will address those criteria. Right there is the first filter that will ensure that there's going to be some traction to that idea that will eventually get funded.
Thank you. Ryan Kastner, please.
Thanks for the talk today. My question, so this is a design automation conference, of course, and we're working on designs, and my question is sort of focused research university. We need benchmarks, basically, and that drives a lot of the work that has been done in this conference over the years, placement benchmarks, routing benchmarks. The challenge is that no one wants to give academics benchmarks because the companies don't want to give up their IP. And I think this is even more challenging for security because you don't want to talk about those flaws.
Yeah.
And let me give you an example. So Trust Hub is a great example where they have benchmarks for hardware Trojans, and there has been a crap ton of research on hardware Trojans, more than I think is necessary in my opinion. But we don't have other benchmarks for other things, right? So how do we address that gap? How do we get benchmarks that are relevant to what you want in security, hardware security, to the academics so that they can work on real problems and make an impact?
Yeah, it's a great question, and it's also an opportunity to talk about the security of microelectronics. So as you obviously know, what the DoD does is to leverage what industry has in place. Whether it's the SAE or whether it's the ANSI standards or any of those standards bodies that have been developing standards. There's the ISO 20243 or the NIST 800-161 or the 171. Those are all standards that have been in place for some years, as you know. And so what DoD does is to leverage those standards. I think it's a misconception to think that somehow we have people within the DoD who come up with creative ways of developing new standards. It's really about leveraging commercial standards. Now, having said that, the challenge we have is for our platforms and systems, there may be a need for additional security beyond what the commercial industry might require. Although, as Andreas has pointed out, there are certain applications, such as automotive applications, where there's stringent requirements, and so that's very encouraging. But again, the congested, contested environments that the DoD has for communications, as an example, or the warfighter, you don't see that kind of threat scenario in the commercial space. So we have to think about a different set of benchmarks, as it were, right? So that's where the JFAC comes in. So when I talked about the levels of assurance that the JFAC, for example, derived for FPGAs, those are exactly the benchmarks that I was referring to. So they certainly have been looking at benchmarks for FPGAs, for ASICs, commercial off-the-shelf, and so on and so forth. What I would encourage is an interaction with the JFAC to better understand what they have developed. Some of this is already published, it's out in the public, and so we certainly can leverage those as well. But again, I do want to emphasize that the way the DoD operates is to leverage what commercial industry, what the public has developed, and then figure out the best opportunity for the DoD for specific mission scenarios, for specific systems, for specific platforms, and so on. But it's a great question. I appreciate it. And we continue to have dialogues and conversations on both sides. I believe it's got to be a public-private partnership. That is a true answer.
Okay. I think there's a tremendous opportunity, just real quick, with RISC-V coming out in open source hardware for those benchmarks, but they don't have much security in them. So I think you need to push on the security for those.
Right.
Absolutely.
So we are almost out of time. So one very quick question with a quick answer, if I may ask.
So very quick question. So Dominic Rizzo, I run the Open Titan project. You're speaking about security and RISC-V. So you talk about the lack of transparency in the supply chain being a very serious issue, which absolutely is. Has there any consideration being given to sort of the utility of these, I'm going to go ahead and say, high quality open source projects to increase that level of visibility, increase that level of assurance that's possible to get for your application space?
Absolutely.
One minute.
There is certainly a need for better visibility into the supply chain. The Amaro tool that I talked about is doing exactly that. Because we have visibility to some extent, into that supply chain, but it's informed by, the tools and resources that are available to that particular tool, that's Amaro. But without a doubt, we want to evaluate things like MQA, quantifiable assurance, which conceptually is so simple. You get the data from across the supply chain, evaluate the data for assurance. But as you can imagine, it's much harder than is conceptually possible. And so that's the challenge that we need to address.
It's all easy in theory.
There you go. Exactly.
All right.
Thank you.
We're exactly on time, right, in terms of the session. So one more time, Dr. Shenoy, thank you very much.
Sure. Thank you all. Yeah.